Good morning to all of you. I am ArulJothi, working as Assistant Professor in the Department of Computer Science, Fatima College. Today we are going to discuss some basic concepts in message passing in distributed operating system. So we have two types of message passing basically. One is shared memory approach and another one is message passing approach. Here is the diagram which illustrates the shared memory approach. In shared memory approach, two processes share some information through a common memory area, whereas in direct memory approach or message passing approach, message is transferred directly to another process from one process. So in this message passing approach concepts, we are going to discuss two important methods. One is synchronization and another one is buffering. So what is synchronization? Doing some activity at the same time is known as synchronization. For example, if we have to work at the same time, we have to synchronize the clock of two different systems. So this is one example of synchronization. Here we are going to see two types of synchronization. One is blocking and another one is non-blocking types. So when it is blocked means if a sender sends some request to the receiver, unless the receiver receives that particular information, the receiver is blocked. In non-blocking semantics, it is not blocked. We can send any information, any number of informations to the receiver. So a primitive is said to have non-blocking semantics if its invocation does not block the execution of its invoker. So otherwise it is known as blocking type. So we have to see in 2 points, two views of points. One is send and another one is receive primitives. That is from the sender point of view, and another side, that is receiver point of view. So in blocking send primitives, after execution of the send statement, the sending process will be blocked until it receives an acknowledgement from the receiver that the message has been received. Whereas in non-blocking send primitives, after execution of the send statement, it need not wait for the sending process. It can proceed with its execution as soon as the message has been copied to a buffer. Next, in receiver side, that is blocking receive primitive, after execution of the receive statement, the receiving process is blocked until it receives the message. For a non-blocking receive primitive, the receive process proceeds with its execution even after the execution of the receive statement. So the important problem or issue to be handled in non-blocking receive primitive is, that is, polling and interrupt. One of the following two methods is polling and interrupt. In this method, a test primitive is provided to allow the receiver to check the buffer status. The receiver uses the primitive to check periodically and poll the kernel to check if the message is already available in the buffer. Another method is interrupt. In this method, when the message has been filled in the buffer and it is ready to use by the receiver, a software interrupt is used to notify the receiving process whether to continue with its execution without having to issue unsuccessful test request. And another variant of non-blocking receive primitive is the conditional receive primitive. It returns control to the invoking process almost immediately with the message or with an indicator that no message is available here. In a blocking send primitive, the sending process could get blocked forever in situations where the potential receiving process has been crashed. To prevent this situation, blocking send primitives use timeout mechanisms. So timeout value may also be associated with the blocking receive primitive. To prevent the receiving process from getting blocked indefinitely in situations where the potential sending process has crashed or the expected message has been lost on the network, due to some communication failure. For example, here is the diagram that shows the two processes, that is synchronous and asynchronous. Here, and the sender sends a message, and from the receiver side, the execution is resumed until it receives the message. And after it received, it sends an acknowledgement to the sender that it has received. Then only the sender starts its other work. So this is the diagram that illustrates the synchronous mode of communications with the blocking primitives. That is, from the receiver side and the sender side, the execution will be suspended when it is processed. So the main drawback of the synchronous communication is that it limits concurrency. That is, we cannot work it concurrently, and it is less flexible. And in a system that supports multiple threads in a system in a single process, the blocking primitives can be used. So a flexible message passing system usually provides both blocking and non-blocking primitives. If we need, in some cases, if we need a strong security transaction, then we have to use only blocking, and in some cases we need non-blocking. So altogether, if we use both this blocking and non-blocking concepts, a flexible message passing mechanism can be produced. So next concept we are going to discuss is buffering. Buffering is nothing but messages can be transmitted from one process to another by copying the body of the message from the address space of the sending process to the address space of the receiver process. So in some cases, the receiving process may not be ready to receive a message, that is, it can be crashed or something. So in these cases, the operating system will rely on the receiver having a buffer. So due to communication failure, the receiver will not be ready to accept the message. At that time, we can use a buffer to store the temporary message. So we have different types of buffering. Out of this, first one is null buffer, that is no buffering. We have no buffer storage area. So in case of no buffering, there is no place to temporarily store the message. The message remains in the sender process and the execution of the send is delayed until the receiver is ready to accept it. So this message is simply discarded and the timeout mechanism. So if the receiver is not ready to accept the particular process, then we have to use timeout mechanisms. After some time, it should be discarded. And the next one we are going to discuss is single message buffer, that is using a single buffer to store if the receiver is somewhat delayed than the sender. So in this strategy, a buffer having a capacity to store a single message is used on the receiver's node. This is because in systems based on the synchronous communication, it will be blocked. The main idea behind the single message buffer strategy is to keep the message always ready for use at the location of the receiver. So to make it fast, the transaction, we can use this. But more than if the communication failure time is more, then we need some more space to store. So for that purpose, we can use two types of storage buffering, that is unbounded capacity buffer, and then another one is finite bound capacity buffer. In unbounded, by the name, it will be unbounded means it is infinite. We can store as much message as possible. So we need not wait for the receiver to be ready. There may be several pending messages that have not yet been accepted by the receiver. Therefore, an unbounded capacity message buffer can store all unreceived messages. But if from the receiver point of view, it is not the communication failure is not rectified, or the particular receiver is not rectified from crash, then the sender will send the messages at a time, and it receives no response. Then we have to set some waiting time. So for that purpose only, we are going to finite bound or multiple message buffer. So unbounded capacity of a buffer is practically impossible. So we go for this finite bound. So we fix a limit for the buffer size. So if the sender sends the message more than the buffer size, then it leads to buffer overflow. The buffer overflow problem can be dealt with in one of the following two ways. That is, one is unsuccessful communication and another one is flow controlled communication. In this method, message transfers simply fail whenever there is no more buffer space. So the sender normally returns an error message to the sending process. So this use of this method makes message passing less reliable. So next we go for this flow controlled communication. The second method is to use flow control, which means that the sender is blocked until the receiver accepts some messages, thus creating space in the buffer for new messages. So this method introduces synchronization between the sender and the receiver and may result in unexpected deadlocks. So last one is multi-datagram messages. Almost all networks have an upper bound on the size of the data, that is maximum transfer unit. This size is known as. The message whose size is greater than this MTU has to be fragmented into multiples of the MTU. So each fragment is sent in a packet that has some control information. So each packet is here known as datagram. So messages smaller than MTU of the network can be sent in a single packet, whereas it is greater than MTU means it has to be fragmented into multiple packets. Such messages are known as multi-datagram messages. So thank you, students. If you have any doubt in this topic, we can discuss in the next session. Thank you.